Hello students, you are welcome to chemistry class once again. My name is Adebanke. I'm your tutor for this class. So in the last video we discussed about introduction to chemistry. In this video we'll be focusing on properties and classification of matter. Get your writing materials ready. Hi students, you are welcome back to class. So the objective for this topic is matter and its properties, and you should be able to classify matter and also differentiate between elements, mixture and compound. So what is matter? When you think of matter, is anything that occupies space. So anything, I mean anything you can think of, be it you yourself, human being, a vehicle, a chair, a table, anything that has mass and occupies space. So look at the example here. Matter is anything that has mass and take up space. So look at a person, a computer, a chair. So those are examples of matter. Anything you can think of, a vehicle, a chair, a standing fan, just anything that has mass and it occupies space. So moving on, there are three major states of matter, three known states of matter. So we have the solid state, we have the liquid state and the gaseous state. When you talk about the solid state, if you look at this picture well, you will see that the solid states, they are tightly packed. So the particles in a solid are tightly packed, usually in a regular pattern. Look at this picture, you see that the object, the particles there, they are fixed together, they are tightly packed. And also, what are the characteristics of a solid state? Particles in a solid state will vibrate, but they cannot move past each other. Why? Because they are tightly packed. So, and another major characteristic is that solids retain their shape. They have their shape. They don't take the shape of anything, any container that you put them in, they retain their shape. Look at the liquid state. The liquid state, from the picture, particles in a liquid state are close together with no regular pattern. Besides, the solid state has a regular pattern. So the liquid state, they don't have any regular pattern. Anywhere you swirl it to, they just move by it. So particles in a liquid flow can easily move or slide past one another. So if you swirl it to one side to the other, so it moves. They are not tightly packed together, just like particles in the solid state. Liquid assume the shape of containers. If you put, for example, water inside a cup, it takes the shape of the cup. If you put it inside a bottle container, it takes the shape of a bottle container. That's why you can say a bottle of water, a glass cup of water, because the content takes the shape of the container. Looking at the gaseous state, particles in a gas are well separated with no regular pattern, just like the liquid state. They do not have a regular pattern. And also, particles in a gas vibrate freely at high speed. They diffuse easily. So gases also assume the shapes of their container. So I have a question for you. What are the similarities between the gaseous state and the liquid state? I mentioned two. So make sure you drop them in the comment section. Then we'll move on to the next subtopic. Properties of matter. What are the properties of matter? we have extrinsic and intrinsic properties.
Hello, if you are enjoying this video and want to see more content relating to this towards your examination success, make sure you like this video, make sure you subscribe to this channel, share it with your friends, okay? Because we will be releasing loads and loads of beautiful content tailored towards your examination success in one sit. Now let's get back to the class.
What do you mean by extrinsic properties? Extrinsic means it does not depend on the amount of matter. Like, it doesn't depend on the weight, it depends on mainly the features. So it doesn't depend on the amount, how much it weighs, the length. No, that's extrinsic, just the features. So what are the examples of an extrinsic properties of matter? When we say extrinsic, we say color, the odor. Can you weigh those objects? No. Those terms. We can't weigh color. We can only define color if it's blue or it's green or yellow. So odor, the luster, boiling point, freezing point. So these are extrinsic properties of matter. For intrinsic, it depends on how much a matter weighs, the amount of a matter. Here we talk about the mass, we talk about the weight, we talk about the volume. We can measure the volume, we can measure mass. So, and another striking difference is extrinsic can be used to identify a subject, a substance. Like you can say a book as a blue cover page. So it can be used to identify. Why intrinsic can't be used to identify a substance. I have another question here. What's heavier? A ton. Which one is heavier between a ton of brick or a ton of feathers? So this question is very simple and straightforward. You can also drop the answer in the comments section. Now to classification of matter. Matter can be classified in three ways. We have mixture, elements, and compounds. So here we have matter can be classified into mixture, then elements, then compounds. So when you say mixture has to do with combination of two or more components, and we have two major types of mixture. Mixture can be classified like when you have two or more composition of things, you will have a phase. So mixture, you can have a mixture as homogeneous mixture, homogeneous mixture, and heterogeneous mixture. When you say homo means one, then hetero means one or more. So for example, let's go back to the slide. Homogeneous, what are the differences between homogeneous mixture and heterogeneous mixture? Homogeneous mixture, individual components of the mixture can be seen and distinguished easily. That's homogeneous mixture. Cannot be seen, sorry. For example, you have a mixture of salt and water. The salt dissolves properly in the water and it forms a mixture. And so you can't even see the salt except the mixture is tasted. Then you know that okay, this component is or mixture is a salt water. But For heterogeneous mixture, think of mixing a sand and a water. The sand doesn't dissolve totally, doesn't even dissolve in the water. Then you see two different colors. You see the sand in the water, and that's an example of heterogeneous mixture.
Hi, I know you're enjoying this video and would like to see related materials and content. We have loads and loads for you in store. Make sure you like this channel, subscribe, hit the subscription button right now, and share with your friends and colleagues so that when next we release the next video, YouTube will notify you. Now let's get back to the class.
So homogeneous mixture, it cannot be seen, it dissolves and it gives one phase. But heterogeneous mixture, individual components of the mixture can be seen and distinguished. You can easily see the sand inside the water. Or think of having a water plus some maybe fillings, maybe you put some iron fillings. You can easily see these iron fillings because it doesn't dissolve. So that's an example of heterogeneous mixture. Another difference is between heterogeneous and homogeneous is that for homogeneous mixture, they may or may not have a variable composition. That means different particles may be in the same ratio throughout the mixture, but for heterogeneous, different particles are in different ratio. They are different in different ratio. For example, for homogeneous, like I stated earlier, salt and water. For heterogeneous, the mixture of salt and iron fillings. Just imagine it. You see that those salt and iron fillings, it doesn't mix together, so you have two different pieces. Now, this picture also gives us a good illustration of what homogeneous and heterogeneous mixture. See, sand, this is a glass of water. Sand plus water. You see, you can easily sight the sand in the water. That's heterogeneous mixture. It's as simple as that. Then sugar plus water, once dissolved properly, the same, you can't even see the sugar in the water, so it dissolves totally. Then you have a homogeneous mixture. Everything mixed together and form one phase. So we've talked about mixture. Let's take elements and compound. We've talked about one. We said earlier that matter can be classified into elements, mixture, and compound. So we talked about mixture. For elements can be described as a pure substance that consists of only one type of atom. What is an atom? An atom is the smallest unit, the basic unit in a chemical reaction or in a compound. So you can see elements, different elements. I know you've heard of periodic table, consists of various elements, hydrogen, helium, lithium, beryllium, and so on. Consists of elements. This is an example of what the periodic table looks like. So all these, hydrogen, helium, lithium, sodium, magnesium, all these, they are elements. Each of them, they are elements. So what is a compound? A compound is a compound of things. What comes to your mind is it's not one thing. It comprises of one or two things. So compound, chemical substance made up by two or more elements that are chemically bound together in a fixed ratio. So all you need to highlight on the key important words there. It's made up of two or more, and it doesn't stop there. That are chemically bound together, doesn't stop there, but in a fixed proportion, in a fixed ratio. Let's take for example water.
Hi, if you are preparing for an exam, this channel is for you. We have loads of content for you, which we'll be releasing in coming days and weeks. Make sure you like this channel and subscribe to this channel so that as soon as you are releasing those videos, you'll be notified by YouTube and you can have success all in one sitting.
We have the hydrogen elements. and we have the oxygen element. And this hydrogen plus oxygen gives us water. This is an example. This is water. This is an example of a compound. So hydrogen plus oxygen giving us water, or an example of a mixture also. Or take for example alcohol. For your alcohol, you have mixture of elements like your carbon, hydrogen, and oxygen, and that gives us alcohol. We'll see that in the slide. So this is what I was explaining. This is an element, helium and oxygen. Those are elements. They contain only one kind of atom. You see, the helium, then oxygen, just one kind of atom. Then when it comes to compound, it doesn't stop at one. That's two or more. So compound contains two or more kind of atom. You see, you have your hydrogen and water, and oxygen, sorry, giving us water. That's an example of a compound. So what are the differences? When you say state the differences between mixture and compound, no, we have elements, we have mixture, we have compound. So what are the differences between mixture and compound? Compound are formed as a result of chemical reaction between two or more elements. There's a chemical reaction that takes place, like alcohol. There's a chemical reaction in terms of fermentation in the presence of oxygen, even some in the absence of oxygen. So there's some chemical reaction that takes place. So what are mixture? Mixtures are formed by simply mixing two or more constituents. This one, a chemical reaction does not really take place here. Number two, the components of a compound are present in a definite ratio. For mixture, they might not be present in any ratio. Then for compounds, properties are entirely different from the constituents. You just get another thing entirely. As a result of chemical reaction, chemical changes occur, then you get a total, like another form of result entirely. For mixture, the properties as those are the same as those of this constituent. For example, you mix water and salt, you get salt water. The water is salty, so it's like almost the same with it. But for example, maybe for alcohol, it might not necessarily be the product and the substrate or your starting material. You get another result entirely. So that's what it is. For compounds are always homogeneous in nature, while mixtures, they can be homogeneous, they can be heterogeneous. Compound formation is accomplished by heat. There are a lot of energy that are being put in place. Heat, energy, electrical energy. But for mixture, heat or electrical energy may not be involved during the formation. Like I said, water and salt, you don't even need any heat. Once you combine it, you get your salt water. But for compound, it involves a lot of heating, a lot of, for chemical reaction to speed up. There are some reactions that you need to heat up for maybe the enzyme to speed up the enzymes or to speed up the reaction to get a result. So that's a chemical reaction. But for mixture, just combine. You don't even have to use heat, like your salt and water, sugar and water. You might not just dissolve. So that's the difference.
Hi, if you have not subscribed to this channel, you can do so in 5 seconds. 5, 4, 3, 2, 1. And don't forget to hit
So that comes to the end of today's topic, and I know you'll be able to understand what matter is, classification of matter, properties of matter, and the different states of matter. So that's what we've talked about or discussed about in today's class. And if you have any question, you need clarity in some things, you can drop them in the comment section and it will be attended to. We hope to see you in the next video, and thank you for watching.